I will start my demonstration by showcasing the website I used for this assignment. You can visit the website by typing in the domain name welcome to my website.tk into your URL, and you'll be greeted with the default page here, which has some text on it. You can click the screen to get some fireworks. There is the second page that can be visited by typing in the following path: application1 app1.html, and this just shows some basic text on a HTML page. And you can also request an image by typing in the following path: images logo.png. You can also see that the website uses SSL encryption and that our connection is secure. I'll now move over to my AWS Management Console. I'm currently logged in as an identity access management user called admin, as we can see here. It is recommended by AWS to use an IAM user rather than your root login to perform most of your daily tasks. You can view your IAM users by going to your IAM dashboard, and you can see that we currently have one user created. This user is admin and has been assigned to a group we created called administrators. This administrators group has the policy administrator access assigned to it, and this allows our user to perform most of the tasks that are required, such as creating instances, security groups, and key pairs. However, they cannot look at certain dashboard and resources such as billing. So if we go to My Billing Dashboard, we will see that our IAM user does not have permission to view this dashboard. Before looking at the instance I currently have running, I just briefly want to mention key pairs and security groups. For this assignment, I created two key pairs, and these key pairs are assigned to an instance when they are created and allows us to connect to that instance through SSH. For the gateway server, I created the server-1-gateway key, and for the web server, I created the server-2-website key. Security groups are firewalls that are implemented at the instance level, and they essentially block all traffic except for the ones that we specify to allow. So for the server-2-website security group, which is associated with the web server, I've allowed any traffic to connect to port 80 and port 443 to view the website. However, I have only allowed the private IP from the gateway server to connect to port 22 and allow it to SSH in, and this is based on the requirements for the assignment. For the server-1-gateway security group, I've essentially just allowed any traffic to connect to port 22, and this is based again on the requirements for the assignment so that anyone can connect to this gateway server. So now that we've covered key pairs and security groups, we can look at the instances I currently have running. I currently have two instances running, one called web server, which is used to host a website, and one called gateway server, which is used to connect to the web server. Looking at the details for this instance, we can see what type it is, as well as information such as the key name that was assigned to it, and the security group that was assigned to it. If we look at the web server, we can see similar details, but we've also seen that an elastic IP has been associated with the web server. This is useful in case an error occurs with the instance. I can simply reassign the elastic IP to a different instance and not have to worry about reassociating the domain to a new IP address. The final AWS service I'll be discussing is the Route 53 service. I used Route 53 for this assignment, which is an AWS domain name system service. If you're hosting a website or running a web application on an EC2 instance, you can route traffic for your domain to your server by using Amazon Route 53. I'm currently in the public hosted zone that I created. Public hosted zones contain records to specify how you want to route traffic on the internet. I created two additional A records to route internet traffic for welcome to my website.tk to the elastic IP address of my website instance that we saw earlier. Route 53 automatically assigns 4 name servers when you create a hosted zone. To ensure that the domain name system routes queries from my domain to Route 53 name servers, I updated my DNS service NS records. I accomplished this by logging into my Freenom account and entering the names of the 4 Route 53 name servers from my hosted zone. So this concludes my overview of the AWS Management Console and my setup using AWS. We can now begin to look at connecting to our running instances. If you select an instance and hit the Connect button, it will explain to us how we can SSH into the instance using the key pair that we associate with it. I'm going to demonstrate that it is not possible to SSH into our web server instance from our current host. And this is because in our security group's firewall, we specified that only the private IP of the gateway server instance will be allowed to connect to port 22 and SSH in. As you can see, if we attempt to connect, our connection will hang and it will eventually time out. In contrast, we'll be able to SSH into our gateway server instance because in our security group, we specified that any IP could connect to port 22 and attempt to SSH in. And this attempt is successful. On the gateway server instance, I've stored the server key for the web server instance. From here, we can actually SSH into our web server instance. And our attempt was successful. If we look back to our attempt to try and SSH into the web server instance from our host, you can see that the connection is still hanging, and it will eventually time out. Now that we're on the web server instance, we can check to see if the Nginx web service is running. As we can see, the Nginx service is running. Listing the contents of the home directory, you'll see that there are two folders called data and public HTML, and these contain the contents of my website. To serve the pages and images, a configuration file needs to be created in the etc nginx conf.d directory. Listing the contents of this directory, we see the file called server1.conf, which indicates where to serve the different pages and content from. Opening this file and viewing the contents, we can see that the server name to my domain name has been set to my domain name. And I also have my SSL certificate and key set to the free Let's Encrypt certificate and key I have located on the Ubuntu machine. We can also see that the server is listening on port 443. I've also added a HTTP strict transport security HSTS policy to my configuration, which will reroute all traffic from port 80 to port 443. I did this because I felt that it was more secure for users to be redirected to a HTTPS rather than to be allowing them to use HTTP to view the website. Below these configurations, you can see that I have set my public HTML folder as root, where my index.html page will be served when people visit my website initially. I'll now provide a live demonstration of a modification being made to the website. To do this, I'm just going to change some of the text on the index.html page. In the index.html file, I'm just going to change some of the text to say something different. So I'm just going to say, thank you for visiting my website. And then we're just going to save these changes. And then we're just going to simply reload the Nginx to implement these changes. Now, if we go back to our website and view the website, you'll see that the text has changed to thank you for visiting my website. As an added layer of protection, I added some rules to the IP tables for both the web server instance and the gateway server instance. These are some rules to prevent common SSH brute force attack, as well as enable HTTP and HTTPS traffic, and allow services to communicate with each other on the instances. As you can see here, these are all the rules that I implemented, and I implemented a subset of these rules on my gateway server instance to focus on preventing SSH brute force attacks and allow services to communicate with each other on the instance. Finally, I'm just going to scan both my instances to check the ports and services that are open. So we can see that port 22 has been discovered on the gateway server as expected, and this is because any IP can connect and access this port. And we can also see that port 443 was connected, and this is expected as well because it's being redirected from port 80 to port 443, and port 22 can only be accessed by the private IP from the gateway server.